it up as soon as possible. So I'm presenting on behalf of the other authors. Hi, I'm Divya Shri. My paper is identification of clear veins for nerve eye using augmented reality. So first, I'll be talking about um, yeah, I'll be talking about what NERVA is. NERVA is basically an inflection of nerve. So it is an integration of augmented reality technology as well as biomedical imaging techniques. So here I'll be offering we are offering real-time vein processing using an Android smartphone. We are making use of Android smartphone in order to project the 3D objects. And this in turn scans veins. This utilizes other forms of factors such as contrast and enhancement and smoothing of the picture, and also it acquires all of these with the help of a smartphone. So Nervar is at the forefront of the revolution. So a lot of healthcare sectors and other domains have been making use of augmented reality applications. So these provide X-ray vision, and also it reveals the internal features that are difficult to see otherwise. So I'll consider an example. So let's say a clinician is trying to detect veins in a patient. So some of the reasons why the patient why the nerves wouldn't be detected is because some of the patients, if in case they are dehydrated, the nerves wouldn't be detected, or it'll be difficult for the clinicians to detect nerves. So in case of old age people, it's a little complex to detect nerves. So some of the patients will have thinner layer of nerves, and some would be healthy. We won't be able to figure out who they might be. So I'll consider another instance. So the AR technology, it converts the heat signature of a patient's veins into an image. So this draws the success rate of blood draws and other vascular procedures. So also augmented reality is a form of technology that superimposes data or images directly onto real objects or any environment. So it connects the real world to the digital world. So here we are making use of venous blood. So blood is basically found in veins, and it is obtained beneath the capillaries of the tissues. So next, the literature survey. I've considered few of the papers where I can take references from. So first one is near infrared illumination. So this one, it is actually they make use of a device. The device used in this research is connected and controlled through a Bluetooth. So here they are making use of a Bluetooth based biometric system. Again, biometric systems are considered to be a traditional system. So that is why they are making use of Bluetooth technology in this. The second one is augmenting reality for augmented reality. Here they are making use of a fingerprinting technology. So if in case this happened in terms of pandemic, so it is a little complex and scary in order to use fingerprinting at this point of time. So that is another drawback. And also they are making use of intravenous cannulation. So intravenous is like yeah, slamming of skin in order to draw these veins, draw blood out of these veins. So these are all considered to be traditional methods used in order to draw blood. And also there's the third one is the infrared hand vein detection system. Here they are making use of a detection system that is infrared radiation. So if in case you're making any surgeries or doing any surgeries for other parts of the body. So let's say for the eyes, infrared radiation is considered to be a little damaging. So this is one of the drawbacks of this paper. Next, moving to the architecture. So you have a camera. The camera captures these modules and processes it, and then it is moved to marker tracking module. I'll be talking about marker tracking module in the next slide. And then the marker tracking module is superimposed on top of the image in order to project a 3D model in front of you. I'll show you the image how this has been projected. So, talking about marker-based technology, it is basically referred to as a trigger photo. So, it actually experiences, it requires a static image. So, let's say you're in front of the camera, and the use of the basic camera is it doesn't detect based on an object. So if you're in front of the camera, other objects will be detected apart from you, or let's say both of it at the same time. But the use of marker based technology is that wherever you are, like right in front of your camera, it detects based on the pixels that have been marked around you. So that is the whole point of marker based technology. So this is the module design. Here you have a camera which captures an image, and also in the computer, basically the machine, you have a computing module. The tracking module tracks all of the images and pixels that have been captured, and also the ones that have been brought together in the database. And we are making use of something called Vuforia. Vuforia is an application. So I've made use of the developer website in order to update these images in Vuforia website. So, and then the images are rendered as well as projected in the form of an augmented reality image. So the algorithm explains just about how I mentioned in the module design. So this is the algorithm, and also this is the image on the left is a 3D model. I've just considered a 3D model in order to project. So the 3D model is not just projects in front of the screen. It also speaks about uh, what happens around in the when you're drawing a blood. So towards the right, you can see a clinician drawing blood with the help of it. So here I can either make use of a smartphone, or I can project it with the help of an A4 size sheet which has the image in front of it, or maybe let's say another projected image in a plain background. The other example is here the image that you see on the left has been superimposed on top of it. So the image on the right has been projected on the screen. So this helps clinicians in order to detect where the nerves are and where you can draw blood with the help of it. Conclusions. So the goal of developing NERVA was to create a low cost and conveniently portable vein mapping device. So here AR images, they do not move to the robot's camera movement. So they must be manually relocated. So to overcome this, we have applied vision based tracking. So it tracks based on I will just consider an example. So in Vuforia website, you have something called as a 5-star to 4-star rating. So you have to detect in order to proceed further, or in order for the image to be projected, the 3D model to be projected in front of you, it needs at least a minimum of 4 or 5-star rating. So that is the main aim of this project. So it needs a 4 to 5-star of rating in order to detect all the pixel points in the image and to be projected in front of the screen. And also uh, to take advantage, so an Android smartphone has been incorporated, and also the general practitioners, they have been very reliant on the successful electronic feature in order to provide a high quality care for this project. So these are some of the references that I have taken into consideration.
Thank you, Divya, for your wonderful presentation.